All right. All right. Let's see if that's going. Yep. Oh, good. All right. Now, if you watched my other videos, we're going to talk about black holes. Black holes are dualistic corpuscular time-shared spaces, particle reunitizing reality makers. Now I was talking about how theoretically, this is basically theoretical concepts of what a base particle would be, another dualistic corpuscular time-shared space, because of a special property of space. Space, if you take a piece of space with nothing in it, doesn't matter how big it is or how small it is, if it's just the space and no energy, that's what we're looking at right now. And that might not really be, this is more like a mental experiment than it is an actuality, okay? Let's say, yeah. So in this mental experiment or test or thought process, we're just taking the space particle of all space, and we're taking away all the energy out of it, and what's left behind is just space. And space is a special property of space-time. So the singularity looks at a space particle, all of space that's in the it doesn't differentiate between size. In its opinion, that space particle is captured because there's no because of the properties of the space particle, it's indivisible, you might say. But if you do divide it, then if you take a smaller part of space and compare it to a larger part of space, and you have no frame of reference, each space is still exactly the same. That's why I argue that there would be able to be stable tiny singularities. And because from its own frame of reference, it doesn't really matter at all. But now we go to the energy thing, which is the energy inside of those singularities would be different. So inside of the small, let's say the Earth, if you crushed it down to the size of a pea, it would be a singularity. But we don't want to. I'm more interested in particles. So the base particle, I believe, is a singularity, and that would be the size of somewhere around a Planck length. And because of the nature of singularities, I would believe that it's likely smaller than a Planck length, but the base particle, once it's reunitized inside of the dualistic corpuscular time-shared space, would be about the size of a Planck length. And then the space particle would be divided up equal to that, because if you look at it, if you imagine it as though it's a gravity well, and the gravity well goes down like this to a narrow, straw-like feature that goes down to the singularity, you imagine particles stacked in there. This is not a literal concept. It's something for us to be able to better understand a fourth dimensional thing. So now those particles are basically, the singularity is basically held open at this Planck length, or reunitized at a Planck length. Why? Is because the centripetal force of the black hole is pressing down, and the centrifugal force of the particle is creating an equilibrium between the two. Once that equilibrium is established, all of space is divided as the center of space within that space particle, and the particles, and those base particles. Then the base particles that are ripped apart, the particles that are ripped apart down to the base particles, or base particle, is then reunitized, and that reunitization then creates a new dual corpuscular time-shared space, reunitized. So, from our point of view, we're in one of those reunitized spaces, and that would be space-time. And every dual corpuscular time-shared space has two space-times, and that would be superposition time and space-time. So, I've been listening to tons of videos. I've been doing this for several years now, listening to science and stuff, and it just came to the point to where after my work that I've done so far, which is preliminary, it just became almost, it's almost painful not to share. So, this is my model, so everybody has a model, or at least within the physics world, or particle physics world, or the model of the universe world. Everybody has their own ideas. But, long story, like when I was a kid, I kind of felt like if I went to the direction of the sciences, then there may be my idea between my father and I. He used to tell me about all kinds of stuff. Was that science can become there could be warning, signs and equations and things that guide you, which they're great. Don't get me wrong. I'm in agreement with almost with a lot of it, and as you know, the way that we figure things out is by seeing if it's validatable through experiment. So so many beautiful experiments have been done, and many of them match up with my model, which I'm really thankful for, and I do believe that I can explain. If you're not super interested already because of this dualistic corpuscular time shared space particle reunitizing reality maker, then I'm probably not going to hook you at all. But so here we go. I'm going to read some of my rough draft notes, and then I'll explain as I go through, because it's just the fastest way I can do this for me anyway. Otherwise it could take years, and it'd be nice to get some of this out there now. I'm not saying I want to introduce a sloppy product. I don't at all. I have no desire to do that. But the concept itself is pretty clear, and it's just one thing, and I think it. Oh yeah, I should mention. Hard to say one thing. I don't know, but it's clear in my mind anyway. So when you come to the event horizon, you have general relativity, special relativity, classical physics work great, out here. But when you go past the event horizon, then you want to use that same thing in there. But it's corpuscular in the sense that it's separate. So you're gonna run Einstein's equations will work inside of the black hole, but that event horizon is the point of separation. Also, in a black hole, okay, so we never left the black hole, and the space particle has a manifestation of any particle that can merge within it on its own frame of reference, from its own point of view, is in its own space in the middle. It's in the middle of everything, and at the same time it's alone. But within the space particle, they combine and create degrees of freedom within the space particle, and the singularity doesn't care as far as it's concerned. You're still trapped in the middle of the singularity. So that's beautiful. Okay. Closed door singularities will explain might help explain a lensing effect. And in the case of closed door singularities, what I'm talking about is singularities that don't want to let anything in. Every time they would accelerate something that's coming up to it, and it would get slung around and shot off in a direction. So I'm kind of saying there may be singularities out there that just don't want to accept anything into it. It's going to resist acceptance. And this, I'm getting at is the particle formation. Dual corpuscular time within a black hole would explain superposition, quantum gravity, magnetism as a wake, superposition as a time out of phase, variance wake, out of phase, fuzzy as a wake, back in time experiment as a dual corpuscular reunitized space-time. Actually, the back in time is as if you have a strobe light on and you're rotating a bicycle wheel, and you turn that, when the lights are off and turn that strobe light on, instantly those spokes look like they're traveling backwards. And from that frame of reference, in the dualistic corpuscular time, that's exactly what's happening, because the frame of reference is it's a buffer effect. It's not gonna work forever. Yeah. So, back in time experience, dual corpuscular reunitized time space due to excess mass and density in one position expelling from original singularity explains the flexible nature of time, the bomb experiment, the cat experiment, micro closed door singularity. So that's one I'm. So closed door singularity or micro closed door singularity particles would explain the time test proof. Okay, so actually with the particle creation would be something like, say, a singularity that forms, and it's and there's like a core that reaches from one end of the time space to the other. So like in our universe, it would be as if there was a huge tether, almost like a tornado in the center of the whole universe. It went from one end to the other. When it wraps around on itself, that's when you might get quantum tunneling that could lead out of the singularity. But then if it does quantum tunnel, when it comes out, it would still be a singularity. So nothing might be able to get out of a singularity, but it might be that a singularity can get out of a singularity. And if a tiny singularity was shooting out of a singularity, it may look like those black holes we've seen with two jet streams on either end, and with the jet streams accelerating at like 2/3 the speed of light, or whatever they're clocking that at. It makes sense because they'd be coming out very fast. Then the particles would calm down. What are they coming out as? Are they coming out as X-rays? Are they coming out as... I know that they're supposed to be whipping around the horizon. It's very likely that this is true. I'm just throwing this out there as an idea of what I think is ultimately, like when the Big Bang occurred, that these particles were created somehow, and this is what I'm suggesting. So I'm explaining interference patterns. I do believe in constructive and destructive interference, but I'm also saying that the reason the interference patterns form the way that they do is because of trajectories, rather than, those trajectories are not the probabilities where a dot appears is from a different frame of reference. 90 degrees offset from our reality is where that trajectory interfaces with our reality. So where you have an interface is where you have, when a particle hits the wall, it forms wherever it happens to be on that frame of reference. So I'll get into more of that later. Frames mean... Yeah, so the frame of reference for each particle means that every particle is in the middle of the black hole. And it's just an extended form of relativity from its own relativistic point of view. So this would help to connect general relativity to a quantum. I said quantum relativity, which is true, but I mean, everybody really wants to know about quantum gravity. Quantum gravity is the particle. So you have a singularity. There's a point that is the center point of the singularity. You have a particle that's reunitized. It's not totally destroyed. I know it's, according to science, they say it's completely converted into gravity. But it makes logical sense that if there's a particle that enters, that within the singularity you have a singularity, and that singularity or that particle that has entered has a spin, and that spin is an energy that when it rotates further and further down, it starts to spin faster, faster, and faster. And this is where I'm saying that the reunitization occurs. That's why you don't see light when it goes into singularities, because it reunitizes. And it's not compatible with this space. But in our space, our light is compatible with our space, and our superposition creates the wave function, because that's not fully compatible with our frame of reference to that time-shared space. Makes sense? It does. And so onward. This helps to explain spooky action at a distance. If you simply take two particles that are energetically entangled, and then you separate them at a distance, it's the distance here. You're within the space particle. The space particle doesn't care where you are. It is a degree of free. You gain degrees of freedom, and as far as the point of view of the black hole, it doesn't see it that way. So, for instance, if you have that accumulator in the attractor in the center of the black hole, and you have the particle that's going down, and it starts going around the center of the black hole, and however it wants to, and then the point is that once, because the black hole itself is spinning, and then the particles going around the attractor, and that attractor. So from the point of view of from the point of view of the particle, it doesn't really know it's not going around the attractor. But from the point of view of the singularity, that particle's dead still and trapped. So it's actually, from the black hole's point of view, space is wrapping around the particle, but that trajectory is still happening, and from the point of view of space. So that particle is able to go anywhere within that space, and anywhere within that space is anywhere within this dualistic corpuscular time-shared space, part of our universe. And the two dualistic corpuscular time-shared spaces would be a universe, but there's other black holes that are connected to us, and we may be connected to other dualistic corpuscular time-shared spaces also. We may be sitting as a black hole in somebody else's universe, or dualistic corpuscular time-shared space. Since the universe means all, that's our true system right there. Okay, so onward. Spooky action at a distance. Okay, so we entangle the two particles. I'm going to mark this so I don't get lost. We take the two particles that are entangled, we separate them at a distance. So you have your what I call potential particles, which are space-time, and virtual particles, which are in superposition time. And they're going perpendicular to each other. And so when the frames line up, then you have a coincidence. And so, but we're not talking about that right now. What we're talking about is that those two frames, when they were entangled together, you imagine a trajectory in your mind where one particle is going up and the other one's going down. And then when you test one of them, you took it out of the equation. Now the other one's just going to be going down from our reference. We're only going to see down now, because this one was going up when we caught it. When we caused the what do you call it? So it's out of phase, in phase. So when we cause the in phase of that first test, then we caused the second part of the test to trajectory down only from our point of view. So the frame of reference, even though they're spread apart, it's affected the frame of reference. There's one, okay, so like if this is the frame of our reference, it's going to be, the trajectory is just going to be going down, 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 down. When we test it, that's all we're going to see, because that's what's lined up with our space-time. Okay. Okay, so even a space, just a chunk of space, believed to be by me a Planck length, and that smallest chunk of space, Planck length, is it still is a frame of reference. That's a frame. So any particle can end up on that frame. Exactly how that happens, it may emerge there, or it may pass through. It's very liberated. It's a lot of degrees of freedom, but nonetheless, that matrix, or that core in the center is everything that we are. So again, the manifestation of our space-time is we might call it the white hole of our existence. Not explained like a regular white hole with a tube and traveling from here, if that's what you want to say, or but the true white hole would not be just some random garbage data coming out of the end of some kind of drain or something. Not like that. That's the way I used to imagine it. By the way, the